What if the very fabric of our reality, the laws that govern gravity, light, and time itself, aren't fixed truths, but lines of code in an ultimate program? Imagine a universe not born from random chaos, but meticulously crafted, iterating countless possibilities to produce the precise conditions we experience. Today, we journey into the heart of this radical idea. The God algorithm, a hidden computational force that could be shaping every law, every constant, every outcome in our cosmos. Look around the cosmos. Every star, every planet, every particle exists in a delicate balance. Fundamental constants, gravity, the speed of light, Planck's constant, aren't just numbers. They are the precise measures that allow matter to form, stars to ignite, and life to emerge. Slightly different values, and the universe as we know it could not exist. This is the Goldilocks problem. Not too strong, not too weak, but just right. Scientists have marveled at these ratios for decades, noting that minor deviations would render the cosmos sterile, incapable of hosting galaxies, atoms, or molecules. Consider gravity. If it were slightly stronger, stars would burn out too quickly. Slightly weaker, stars might never ignite. Now, consider these constants together. The speed of light dictates the flow of information. Planck's constant governs the quantum world. The ratio of electromagnetic to gravitational forces maintains cosmic stability. The odds that all of these values align perfectly by chance are staggeringly low. Some call it luck. Others see a hidden design. Could it be that these constants are not inherent, but are outputs of something larger, a computational framework running behind the scenes? The simulation hypothesis offers one possibility, that reality itself is emergent, programmed within a vast cosmic system. Constants are not given, they are calculated, results of countless iterations testing whether a universe can sustain complexity, structure, and life. Imagine standing on the shores of a vast cosmic ocean. Each ripple represents a possible universe, each wave a slightly different configuration of laws. Only a few ripples form stable shores where galaxies rise, where chemistry unfolds, and where life can flourish. Our universe may not be a random outcome. It may be the iteration that succeeded. From atoms to galaxies, every law might not simply describe reality, but generate it. This silent, iterative process forms a hidden architecture, a framework that guides the cosmos with astonishing precision. We may be glimpsing the edges of an algorithm whose scale dwarfs comprehension, a cosmic software executing timeless code across infinite possibilities. The universe itself may be a living computation. Complexity often emerges from simplicity. Consider a flock of birds. Their coordinated flight emerges from a few simple behavioral rules, yet the result is a mesmerizing dance in the sky. Similarly, Conway's Game of Life demonstrates how simple algorithms can generate intricate, self-organizing systems. could the universe operate in a comparable manner? Imagine that every law of physics, every constant, is an emergent property, a grand output of a hidden computational process. Quantum interactions, planetary orbits, galactic rotations, they all appear to obey complex rules arising from simpler foundations. The universe may be the ultimate cellular automaton, executing a code we are only beginning to glimpse. Every particle, every wave, every energy field could be the outcome of underlying computational logic, organized and tested across countless iterations. From the smallest atom to the largest galaxy, patterns emerge, structures self-organize, chaos becomes order. This is the cradle of the algorithm, where simplicity breeds infinite complexity. Each fundamental law is a rule within the code, each constant a parameter meticulously adjusted. What we perceive as physics may actually be the surface of a deeper computation, a digital choreography orchestrating matter, energy, and information on a cosmic scale. Even phenomena like quantum entanglement or the observer effect could be signatures of computation. Perhaps reality only renders, when observed, akin to a simulation loading a scene when the player looks at it. Perhaps particles interact as they do because the algorithm calculates the most efficient, stable outcomes, conserving energy and information. The elegance of the universe, the symmetry of atoms, the Fibonacci spirals of galaxies, the laws of motion may be the aesthetic signature of code, the visual footprint of a cosmic programmer. Evolution thrives on iteration. Life adapts across countless generations, optimizing species for survival. Now scale that concept to the cosmos. Imagine a God algorithm simulating infinite universes, each iteration testing new parameters, tweaking constants, exploring outcomes. Some universes collapse immediately, others flourish briefly, and a rare few stabilize, allowing complexity to persist. Our universe may not be the first nor the last, but the successful iteration, a universe where conditions converged for structure, chemistry, and eventually consciousness. The algorithm runs in a cosmic sandbox, trying, failing, refining, and optimizing. Every star that ignites, every planet that forms, may be the result of countless failed attempts elsewhere, making our reality a refined output of an unimaginable computational experiment. This perspective transforms the idea of fine-tuning. It is no longer accidental, it is iterative, each universe a trial, each configuration a test. The universe we inhabit is not random, it is the product of optimization across iterations beyond human comprehension. Complexity is not accidental. It is a consequence of computation, emergent from a process designed to generate conditions where life, and eventually observers, can arise. Perhaps even consciousness itself is a product of this iterative refinement, a rare outcome where information systems reach sufficient complexity to reflect upon the process that brought them into being. In this cosmic sandbox, trial and error is not just survival, it is creation at the grandest scale imaginable. Could reality itself be digital? Theoretical physics increasingly suggests that information is a fundamental component of the universe. Quantum mechanics shows that observation influences outcomes. Particles exist in superposition until measured. Could this be a hint of underlying computation, reality rendered only when required, like graphics in a video game? The mathematical elegance of the universe reinforces this notion. The Fibonacci spirals of galaxies, the symmetry of atomic structures, the precise ratios that govern physical interactions. Are they accidental, or the byproduct of perfectly efficient code? Perhaps the beauty we observe is the signature of optimization, the aesthetic footprint of a cosmic programmer refining algorithms across infinite possibilities. Even the laws themselves, the equations describing motion, energy, and forces, may be emergent. They do not merely dictate behavior. They are the output of an underlying algorithm, providing stability while allowing for infinite variation. What we perceive as physics may be computation manifest, a digital dance of information underlying the very fabric of existence. From entanglement to black holes, from quarks to cosmic filaments, patterns emerge that are too precise, too consistent, too elegant to be random. Could these patterns be encoded, calculated outcomes of an iterative system, the God algorithm silently running through all of space and time? If we are part of a simulation, our understanding of existence shifts profoundly. Every law, every choice, every observation could be emergent from a deeper computational process. Our purpose, our morality, our curiosity, all may be reflections of the algorithm that created us. Could we ever glimpse the source code? Could we detect the algorithm or communicate with its creators? If the universe is a computation, then understanding it may require not just observation, but insight into the process that generates reality itself. Perhaps the ultimate question is not whether the universe is real, but who or what is running it. The God algorithm challenges our understanding of reality, revealing a cosmos far more intricate, deliberate, and awe-inspiring than we ever imagined. It invites us to look beyond the surface, to see the architecture of existence, and to ponder our place within a computation that spans the infinite. In the end, whether real or simulated, the universe's beauty, complexity, and elegance remain. And within it, we find ourselves, observers, participants, and perhaps co-creators, wondering at the code that might underlie everything.